Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions. The mystery of Enceladus Organic Chemistry. Saturn's moon is producing complex organic molecules that shouldn't be there. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction, not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. Saturn has 146 known moons, and most of them are frozen, airless, geologically dead rocks and ice balls. Enceladus is different. Enceladus, a small moon just 504 kilometers in diameter, small enough to fit inside the United Kingdom, is shooting geysers of liquid water into space from a global subsurface ocean that has been warm and chemically active for billions of years. The geysers, discovered by the Cassini spacecraft in 2005, spray water, ice particles, salts, and gases into Saturn's E-ring at approximately 400 kilometers per hour. When Cassini flew directly through the plumes in a series of close approaches between 2008 and 2015, it discovered something extraordinary. The plumes contain carbon dioxide, methane, hydrogen, ammonia, and most significantly, complex organic molecules including benzene and compounds with masses over 200 atomic mass units. These are the building blocks of life. The methane in Enceladus's plumes is particularly alarming. Methane is a simple molecule that is rapidly destroyed by chemical reactions in warm, wet environments. Its presence in the plumes means it is being continuously produced somewhere in the ocean below. The only sources of methane capable of sustaining the observed rate of production are thermochemical reactions at hot hydrothermal vents, analogous to deep-sea hydrothermal vents on Earth, where life thrives without sunlight, or biological production by methane-generating microbes, methanogens. In 2023, a detailed analysis of Cassini data published in Nature Astronomy found that the methane production rate on Enceladus is consistent with methanogenic microbial activity at a scale comparable to deep-sea vent ecosystems on Earth. The researchers were careful to note that geological explanations cannot be ruled out, but biological ones cannot either. Enceladus has, in summary, a warm liquid water ocean, a source of chemical energy from hydrothermal vents on the ocean floor, complex organic chemistry in its water, and a methane production rate that may indicate biological activity. It meets all four criteria that astrobiologists use to define a habitable environment. And all of these characteristics are knowable from space without drilling, because Enceladus is actively throwing its ocean into space for any spacecraft to sample. No other known object in the solar system makes it so easy to investigate its potential for life. The question is when we will go back to look. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we go further, if you are finding this investigation compelling, please take a moment right now to like this video, drop a comment below with your thoughts, and share it with someone who loves a good historical mystery. If you are watching on YouTube, hit subscribe and tap the bell icon so you never miss a new episode. If you found us through Facebook, tap follow on our page. It takes just a few seconds, and it genuinely helps us keep making these documentaries. Now, let us get back to the investigation. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Space is not quiet. The universe is filled with electromagnetic signals, from the cosmic microwave background radiation left over from the Big Bang to the steady roar of stellar activity at every wavelength of the electromagnetic spectrum. Against this noise, radio astronomers look for something specific, signals that are narrowband, repeating, and structured, the signatures of intelligence rather than nature. Natural processes tend to produce broadband emissions spread across many frequencies. A narrowband signal at a single precise frequency suggests something deliberately tuned, and deliberate tuning implies a tuner. The search for such signals has been ongoing since 1960, when Frank Drake pointed a radio telescope at two nearby stars and listened. In the 60-plus years since, the instrumentation has grown enormously in sensitivity, and the sky survey coverage has expanded from a handful of stars to millions. The verdict so far is ambiguous. No confirmed, repeating signal from an extraterrestrial intelligence has been received, but several anomalous signals have been detected, investigated, and not definitively explained, including at least one that, had it been received today, would meet every criterion the scientific community had previously agreed would constitute first contact. The silence of the cosmos is not total. It is merely inscrutable. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns, in science, demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding Enceladus Organic Chemistry, Saturn's moon, is producing complex organic molecules that shouldn't be there, is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Enceladus was identified as geologically active when Voyager 2 passed through the Saturn system in 1981, noting its unusually smooth and bright icy surface, indicating recent resurfacing. The confirmation of active cryovolcanism came from Cassini, which in 2005 discovered the South Polar Tiger Stripes, 4 parallel fractures approximately 130 kilometers long, from which jets of water vapor and ice particles are continuously erupting. Cassini made 23 close flybys of Enceladus over its mission lifetime, including 3 direct plume transits at altitudes as low as 25 kilometers above the surface, collecting chemical samples of the erupted material. This single data point, if taken in isolation, might be set aside. Anomalies happen, instruments malfunction, researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the subsurface ocean of Enceladus was confirmed by Cassini's gravity measurements and by the detection of wobble in the moon's rotation, libration. The ocean is estimated to be approximately 10 kilometers deep, lying beneath an ice shell approximately 20-30 kilometers thick at the poles, and perhaps as thin as 5 kilometers in the Tiger Stripe region. The water is in contact with the rocky seafloor, where hydrothermal vents are inferred from the presence of nanoscale silica particles and hydrogen gas in the plumes, both signatures of high-temperature water-rock interaction at approximately 90-100 degrees C. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine the complex organic molecules detected by Cassini's ion and neutral mass spectrometer (INMS) and cosmic dust analyzer (CDA) include methane CH4, propane C3H8, ethane C2H6, acetylene C2H2, benzene C6H6, and heavier molecules, some with masses above 200 atomic mass units, indicating molecules with 15+ carbon atoms. The presence of these heavy organic molecules in the plumes implies that complex organic chemistry is occurring in the ocean, likely driven by the hydrothermal vent chemistry that concentrates and complexifies simple organic molecules. On Earth, similar chemistry at hydrothermal vents is associated with the probiotic chemistry that preceded the origin of life. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the methane puzzle was formally published in Nature Astronomy in 2023 by Holder et al., who conducted a rigorous statistical analysis of whether known abiotic, non-biological geological processes could produce methane at the rate observed in the Enceladus plumes. Their analysis found that the methane flux is too high to be easily explained by serpentinization, the most likely abiotic mechanism, in which iron and magnesium-rich rocks react with water to produce hydrogen and methane. The paper concluded that biological methanogenesis cannot be ruled out and should be considered a viable explanation alongside geological mechanisms. This is the most direct scientific statement yet about the possibility of life on Enceladus. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators, they are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the Enceladus Ocean's chemical characteristics. As determined from Cassini d. ADA include a slightly alkaline pH, approximately 9-11, compared to pure water at 7 and Earth's ocean at approximately 8. 1. The presence of dissolved salts, including sodium chloride, sodium bicarbonate, and sodium carbonate, a high concentration of silica nanoparticles, and the complex organic molecular inventory. This chemical profile is remarkably similar to some terrestrial alkaline soda lakes that host thriving microbial ecosystems, including Lake Magadi in Kenya and Mono Lake in California. Some researchers have proposed that the specific alkaline chemistry of Enceladus's ocean may actually favor the origin of life by facilitating the formation of amino acids through the Strecker synthesis. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding: the tidal heating that powers Enceladus's geological activity comes from gravitational flexing by Saturn and the resonance with neighboring moons, particularly Dione. As Enceladus orbits Saturn in a 2-1 orbital resonance with Dione, the gravitational pulls on Enceladus from different directions periodically compress and stretch the moon's interior, generating heat through friction. This tidal heating has maintained Enceladus's subsurface ocean in a liquid state for an estimated several hundred million to over 1 billion years, long enough in principle for life to have originated and evolved in the ocean, if it ever started it. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain Enceladus Organic Chemistry. Saturn's moon is producing complex organic molecules that shouldn't be there. This is where the debate becomes most intense. because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that the hydrothermal habitability theory holds that Enceladus's seafloor hydrothermal vents provide the same energy source and chemical gradients that drove the origin of life on Earth, and that sustain deep-sea vent ecosystems today. Under this model, the vents on Enceladus's seafloor supply hydrogen, an electron donor, and support thermochemical organic synthesis. If life originated at deep-sea vents on Earth approximately 3.8 billion years ago, similar chemistry on Enceladus could have produced similar results. The methane and complex organics in the plumes would be byproducts of this vent chemistry, but they could equally be byproducts of microbial metabolism. The theory is strong but currently unfalsifiable without a dedicated life detection mission. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that the abiotic methane theory holds that all of Enceladus's methane can be explained by geological processes without invoking biology. The two most discussed mechanisms are serpentinization, water reacting with iron-magnesium silicate rocks to produce hydrogen and methane, and thermolysis, thermal decomposition of organic-rich material incorporated into the Moon during its formation. Proponents argue that the methane production rate, while high, falls within the range that sophisticated geochemical models can accommodate without biology. The 2023 Holder paper challenged this by showing that the rate is difficult to explain abiotically, but defenders of abiotic explanations note that our knowledge of Enceladus's interior is too limited to rule out unusual geological configurations. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the prebiotic chemistry theory takes a middle position. Enceladus's ocean is rich in the chemical precursors to life and is actively producing complex organic molecules through vent chemistry, but has not yet, or may never, cross the threshold from chemistry to biology. Under this view, Enceladus is in a state analogous to the early Earth approximately 4 billion years ago. Chemistry favorable to the origin of life is occurring, but life itself has not yet emerged. This is perhaps the most scientifically conservative interpretation consistent with the current data, and it is consistent with both the methane observations and the complex organic chemistry in the plumes. What is striking about this debate is not merely that experts disagree, that is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding Enceladus Organic Chemistry, Saturn's moon, is producing complex organic molecules that shouldn't be there does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes the nanoscale silica particles detected in Enceladus's plumes are among the most significant pieces of physical evidence for hydrothermal activity on the seafloor. These silica particles form specifically when hot, 90 degrees C, alkaline water equilibrates with silicate rocks and then cools rapidly. They cannot form in cold water and require both elevated temperature and silicate rock contact. Their presence in the plumes is direct evidence of active high-temperature water-rock interaction at the bottom of the ocean, establishing the existence of the hydrothermal system. This makes Enceladus one of only two places in the solar system, the other being Earth, where hydrothermal vents in contact with liquid water are documented to currently exist. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the hydrogen gas concentration in Enceladus's plumes, measured at approximately 0.4% by volume, is significant because hydrogen is the electron donor in methanogenesis. The ratio of hydrogen to methane in the plumes can be used as a proxy for the thermodynamic favorability of methanogenic reactions in the ocean. The 2017 Hunter-Waite et al. Paper in Science analyzed the H2/CH4 ratio and found it consistent with conditions where methanogenesis would be thermodynamically favorable, meaning the chemical energy available for methane-producing microbes exists and is accessible. This does not prove that methanogens are present, but it establishes that the environment is energetically suitable for them. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the detection of heavy organic molecules with masses above 200 atomic mass units in both the gas phase and the solid ice particles of the plume is evidence of complex organic chemistry occurring within the ocean. Simple organic molecules are produced readily by cosmic radiation, acting on simple molecules in space. But molecules of 200+ atomic mass units with complex carbon chain structure require sequential chemical synthesis in a medium that provides stability, concentration, and reaction time, characteristics of a liquid water environment, not space. The presence of these large molecules in the plumes is evidence that the Enceladus Ocean is an active site of organic synthesis at a level of complexity not observed in any other non-Earth environment in the solar system. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding Enceladus Organic Chemistry. Saturn's moon is producing complex organic molecules that shouldn't be there. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. NASA and ESA are both evaluating dedicated mission concepts to Enceladus that would conduct more sophisticated life detection experiments than Cassini was equipped for. The Enceladus Orbilander mission concept, proposed to NASA by a team led by Shannon Mackenzie, would combine orbital sampling of the plumes with a lander capability to collect and analyze freshly erupted ocean material on the surface. The mission would carry an organic chemistry laboratory capable of detecting biosignatures, including amino acid chirality, a key indicator of biological origin, and isotopic ratios that distinguish biological from geological methane. The mission concept was ranked highly by the 2023-2032 Planetary Science Decadal Survey, but has not yet been formally approved or funded. The scientific community's growing consensus that Enceladus is the most accessible, potentially habitable environment in the outer solar system has given new urgency to the case for a dedicated mission. Every year that Cassini data is analyzed produces new findings, the 2023 methane paper being the most recent example, suggesting that the plume material contains more information about Enceladus's habitability than could be fully extracted with Cassini's instrumentation. The next mission to the Saturn system, whenever it launches, may answer the question that Cassini posed but could not resolve: whether Enceladus's ocean, warm and chemically complex after billions of years of hydrothermal activity, has produced or now sustains life. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of Enceladus Organic Chemistry. Saturn's moon is producing complex organic molecules that shouldn't be there, from the historical record through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Enceladus ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please help us reach more people. If you are watching on YouTube, subscribe to the channel and hit the notification bell so you never miss a new documentary. If you are watching on Facebook, tap the follow button on our page to stay connected. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment telling us which case you want us to investigate next. The conversation continues. The investigation never ends.